Okay, so is it audible now? I think it is audible. Okay, I think it is audible now. So good afternoon to all the dear students present here. So I welcome you all in the Digital Logic Design Laboratory. Today we will be doing some basic experiments based on the Digital Electronics Laboratory. Okay. Now the thing is that prior to starting of this laboratory, I just want to focus a few points which are required for this lab, right? I think there are different types of issues we all of us are facing during this lockdown period. Not only you, but most of us are facing different issues. Previously, this lab was conducted in the digital lab in the Kolkata. Now the thing is that we have been shifted from this digital hardware lab to this online teaching, right? So we have to actually take some help of the simulators, and I have already posted you some of the simulator links, that is from where you can actually download the Proteus 8.9, and along with that I have also given the YouTube link from where also you can get the help how to install the software. Okay, now prior to this I will go to all these things to the detail of the lab. Okay, before that what I want to share with you is the syllabus. Okay, I will not take too much of time to discuss all these things. I will briefly discuss because I think you people are tired enough to have all the 4 lecture consecutively, so I will not take too much of time to go to the details of this. So I will just briefly discuss what are the week-wise planning of this lab. Okay, so I just request all of you one thing, that if you are facing any problem, you can contact me. I have the WhatsApp number there in the group. If you have any problem, many of you have contacted me regarding the installation problem. So I think Shayon, I do not know from which section he is. He has already sorted out the problem also. So you see, the innovation is within you itself. Okay, you do not require always some teacher to help you. You people are enough capable. I think the new generation is enough capable to do all these types of activities. Okay, that is my point of view. It may differ from one point to another point, but I think the new generation, I have taught 2000, and that is 18 batch, and I have heard the good feedbacks of 19 batch also. So I hope you people will be very bright, very good in the next coming sessions. And maybe there are some faults from my side. I will try to rectify the faults. As of now, I have not been introduced to you because this is my first class. Hopefully I will take other classes, and it's a free platform. You can always talk to me. If you find any problem, you can contact me. The WhatsApp number is given. Okay, now the thing is that this week we will go one by one. The first week, you know what are the things. I think all of you can see the screen, and you can see this. The basic thing is that the basic gates. I think all of you have done the basic electronics lab in the first year, right? So in the basic electronics lab, what you have done, the basic gates, right? The familiarization with the basic gates, and or not, and all these things, right? So the thing is that we will also be doing this, but we will be using some different IC, right? So you have used some different ICs there. So 74ZD IC you have used, but we will be doing the experiments using 4008. Okay, so no need to rush around that we have to do this, that, all these things. Please take your time. You please Those who have already installed the software, fine. Those who have not yet installed the software, no problem, no issues. You take your time for this week. You take 1 week of time. You slowly try to install it. For this week's session, we have not given any complicated problems, okay? Those who have done the installation, they can also give answers. Those who have not done the installation also, they can also give the answer, right? So we are for you only, okay? So because we know your problem, many of you have texted me that you do not have laptop or PC or like that. We feel your problem, we understand your problem. So we are not forcing, at least for this week. At least the thing is that you should learn something and you should love to learn. Otherwise it will be a force to you, right? The thing is that that is my personal view. We cannot force anybody to do a good thing, right? It's an inherent feature of a person that will we are the facilitators. We are not the teachers, right? We are the facilitator. We will ignite you, and you people are much more capable, and you people are I have seen lots of students, because for last nearly 9 years I am been in this teaching profession. So I have seen lots of students who have huge potential. Maybe they are not flourished in the class because we do not actually give time to all the students equally. So we will try to find out the thing is that we always find out who are giving good answers, right? But the thing is that for all students you have some positive things. We will be there to ignite the positive things. Whatever is your inner potential, that will come out. That is the role of a teacher, that of now I think, okay? No, so apart from this, come to the topic now, okay? So I talk a little bit, so please bear with me. So out of track talking is my habit, so in this class I talk a little bit, okay? So I will request two things, okay? Prior to the class I will request two things. Number one, please bring one pen and paper with you, at least to note the basic points, 2-3 points. I am not telling to all the points you need to jot down, but 2-3 points you must jot it down, okay? Those are very essential basic things, okay? Now I think that basic digital electronics subjects, the theory part, Nilanjan sir has already started. You have in the morning session, you have done with the COA lab, okay? So COA lab also you are very much will be interesting. And actually what happens, COA is somehow higher version than digital, right? You cannot go to the next step until you know the first step, right? So the thing is that you need to go a bit higher. You have done already a higher thing, like you have done, or you have used the model sim or like that, you have understood the concept. But the basic thing that I will tell you, okay, I will tell today very slowly, so that each and every point you should understand. I will not rush at all. I will teach very slowly, very basic things, right? So let's start with week 1. It's all and or not the thing you have done already. You have to just familiarize with all these things. But the domain is what we will be doing in the Proteus, right? Many of you, I'm just giving the slide, changing the screen. This is the Proteus platform, right? This is the Proteus platform. Many of you who have already installed it, they might get this one. Those who have not installed it, don't scared, don't get tensed. It will be done. I can assure you it will be done. If time is there, it will be done, okay? Now come to the second part. I will come to the PPT, okay? Two things I want to discuss. Number one is that the advantages of digital over analog. I think Nilanjan sir has already discussed those points. Still I want to focus on 1 or 2 points. Number one, the noise immunity. Please note it down. I am just repeating. That is my bad habit, you can say, that I will be telling the same thing 2-3 times. You can say that is a bad habit. So the thing is that first thing, the advantage of digital over analog is that it is the the noise immunity of the digital system is very high. Maybe in the Google form the questions will be there. What are the advantages of digital over analog? Please have a note on that. The noise immunity is high in case of digital, right? The noise immunity is high in case of digital, whereas the noise immunity is low in case of analog, right? So actually what happens when an analog signal is passed, there are lots of noise sources that used to corrupt the signal, right? So nowadays everything is digital. From morning, it's a clock, it's a mobile, it's a TV, it's a washing machine. Everything we use, even the educational platform nowadays we are using is digital. The nowadays companies are using digital marketing. Everything, the domain has been shifted from analog type of or manual type of things to digital, right? So these are the things we actually want to implement, but we cannot implement until and unless we know the basics of this, right? So these are the things actually. So the second in the first week, but I will not do this one in the first week. The design of, I think it is visible, okay? So design, if you want to see more, so I will just increase this one. So the thing is that there are other experiments apart from the familiarization, that is the how to make a circuit of even odd number system. Suppose in a real time example, nobody will give you a problem, right? That is this function you just implement. The real life things that is happening, there are some causes and some effects are there, right? Can you make all these things shifted to a digital platform? If you find, so you can make the circuit out of that, but how can you make a circuit without knowing anything? So first of all, what you have to do actually, you have to understand what are the input variables, what are the output variables, and from the input and output, from the first year you know that how to draw the truth table, right? Or how to calculate the truth table out of that, right? So the thing is that first of all, what are the inputs that you have to know, what are the outputs that you have to know, and how to make the truth table, that is the thing, okay? So first thing is input, second thing is output, third is the truth table, fourth is from the truth table we will get the equation or the functions. In later classes of theory you will get how to reduce the truth table and how to get the function out of it, and from there we use different types of minimization technique to minimize the function and to miniaturize the circuit, right? I want to miniaturize the circuit. I do not want a big circuit. In real time, do you need a big clock or do you need a big mobile? No. Every circuit which we will be using, it should be in the miniaturized form. So the efficiency of making a circuit lies in what? In reducing the size of the circuit. Okay? That is the thing. So these are the points, that is within 1 week. Second week we will go to a higher version, like we will implement half adder, full adder, half subtractor, full subtractor. Maybe it will take a week 3 also. Then you have the code converters, that is the weighted code and non-weighted code, all these things. I hope you have seen the theory syllabus. Nilanjan sir has given the theory syllabus. So not given, he might have shown the syllabus in this previous class. So different code converters are there, and from the code converter you can see BCD is there, XS3 is there, and all these things, gray codes are there, different types of code converters. Then you have to go for the parity generator and parity checker. Where is the use of parity generator? It is mainly used for error detection purpose, okay? It is mainly used for error detection. I am just going for this even parity generator and checker circuits, okay? So all these things, you have the comparator. It may be 1-bit comparator, it may be 2-bit comparator, like that. Next phase is what I was telling, that you need to use some K-map technique, right? How to miniaturize the circuit? You have to use some K-map technique by which you can actually minimize the circuit component. How will you minimize? As you are using the K-map, the function will be minimized, and then only you can implement the circuit using some least number of components, right? So each component is having some cost, right? If you are having a big circuit containing of huge components, that will lead to higher cost. So I do not want a big circuit, I need a miniaturized circuit, right? Next, there will be some ICs like 4539B, or like this is a Marx IC, right? It's showing Marx IC, okay? Then you have the 3:8 decoder IC and all these things, okay? This is a 4008. Now next phase, up to week 7, you can say week 1 to week 7, whatever you have done up to this is basically the combinational circuits, okay? The combinational circuits. Basically, if you divide the digital syllabus into 2 parts, week 1 to week 7 will be the combinational circuits, and then week 8 to rest will be the sequential part of circuit. So what are the difference between the combinational circuit and the sequential circuit? That I will come to later, okay? What are the difference between the combinational and the sequential? I will come in the due course of time. Only the thing is that you remember that combinational circuit do not require any memory. Sequential circuit requires memory. That is a fundamental difference between the combinational circuit and the sequential circuit. And in the sequential circuit, the unit of memory, actually this is the flip-flop, okay? There are different types of flip-flops available like SR, D, JK and T, and there are different conversions of the flip-flop, right? From one flip-flop to another flip-flop we can convert, and there are methodologies, there are different things. We will come one by one other. Now come to the counter. This counter portion, like week 9, you can see the counter, different types of up counters, down counters, and within that also synchronous, asynchronous counters are there. So it will be synchronous up, synchronous down. You mix up this two, okay, and you can create the types of counters, okay. There are different mod counters, like it is a mod 7 or mod 5 or mod 13, different counters are there. And you know that sir has already told you how there are different usage of counters in practical life, right? So these are the things. I will not take too much of time telling the syllabus and all these things. And you see the Johnson counter, these are another types of counters, okay? So counter is one phase of this part, that is what can I say, this sequential part. It's a very important section is counter. Lots of theoretical questions, or you can say the interviewers used to ask you the questions, okay? So I'm just deviating from this topic. One thing I'm just like to tell, that in theory class also I will tell, digital electronics is a very fundamental subjects, okay? So there are two implications in the placement interviews. They will ask, if you want for a higher education, okay, you go for GATE, okay. I think the last year GATE was conducted by IIT Delhi, and this year GATE will be conducted by IIT Bombay. So whatever the things you people are studying, please study by heart, okay? ভালোবেসে পড়াটা দরকার, you study by heart, otherwise we will do the things, but if you do not love to do the things, it will be a burden to you, right? It will be a burden to you. So we know you have pressure, fine, we all of us know we are that you people are having some pressure. Still try to love the subject, okay? Okay, so this counter and the register are the two things that I wanted to focus. These are very important topic as far as the GATE syllabus is concerned, as far as the placement interviews are concerned. These please try to focus, and please try to make the fundamentals clear, okay? We are there to help you out. If you have any problem, anytime you can just just give the question, you can text us. We will be, maybe at that point of time we are not giving the answer, but definitely we will give the answers, okay? This is all about the syllabus part, right? So now let's come to the presentation part, okay? So to today what I have planned, I'm telling you very frankly, what I have planned, I will try to cover the first experiment, that is realization of this basic gates. Okay, now two three things that I like to focus. You just have because many of you are thinking, why Proteus? There are lots of softwares, right? Ma'am, LT Spice is there, Tinkercad is there. Why you are using this Proteus? It is having a 500 MB of memory. Why you are using this? Now you see, if you are going for the Proteus, there are lots of flexibility added with it. You can create a circuit, you can test a circuit, you can deploy a circuit. Okay, now many of you have seen that you have got the form, right? You have to do some projects on this and you need to make a group and you need to submit it. Okay, so if you want to do some IoT related project, any 8051 microcontroller related project, or any kind of project if you want to do, you require some heavy software like Proteus, and there are huge library content and there are huge amount of circuitry content components present in that. Okay, that I wanted to focus, because last day lot of students just texted me, because they have some genuine reason to tell that they are unable to, but you should understand why we are doing so, because you can, if you are doing a project, you can extend the project up to 4th year, right? So if you are doing a project and you need some solid knowledge on these types of software, so that if you are in the first year and if in the second year, if you are in the second year and you are just doing all these things, I think after 2 years you will be confident to handle the software in all aspects. That is my what can I say, that is my prediction, you can say. Okay, because if you just focus on one software and if you try to implement some of the things using the software, you will be able to do some big project out of that. Okay, I will not take too much of time. Now let's come to the experimental part quickly. Okay, now so I'm just increasing the screen, just so it will be a runtime, right? So there may be fault from my side, because it's a hands-on experiment that we will be doing. Okay, the network is required, all the things are required. Okay, so let's come to the experiment number 1. Okay, this is the thing. Please note it down. What is the title? I request all of you, please know, I'm just keeping this slide here. Just take your time and note it down. What is the, because today you have to write it in the form. Okay, what is the title? Okay, now in this case, you see, for any kind of circuit you need some logic expression, and from logic expression you need to implement those logic expression, right? How will you implement those logic expression? You can implement the logic expression using some gates. So if you have some logic expression, you have to implement those logic expressions using some gates, right? Now what are the fundamental gates? You know the fundamental gates. What are the gates you have? I'm just using one. These are the fundamental gates that you have. That is the basic gates that you have, and 2 gates, NAND and NOR, are known as the universal gates. Now because I cannot ask the question, so NAND and NOR, these 2 gates are known as universal gates, because any kind of circuit, that's any kind of gate can be implemented using this type of universal gates, right? Any kind of gates can be implemented using this type of gates. Okay, now all these things you know, I will take 2 minutes of time to briefly discuss it. Okay, so what is the basic truth table of this one? So the basic truth table shows you that for any kind of gate, that is a AND gate, if you have this one, that is AND gate, if you see 2 input AND gate, you have this A and B, right? A and B, and the product of this two, as if the logical multiplication of this two will give you the output of the AND gate. So only if it is, suppose AND gate, it is 0 0, okay, 0 1, I will come to this one later, 1 0 and 1 1, right? So only when two inputs are 1, then only the output will be 1. This is for which gate? AND gate, right? It will take 2 minutes of time, okay? Now this is the thing. For OR gate, what happens if any of the input is 1, the output will be 1, okay? Now for NOT gate, it is also known as the hex inverter. If the input is 1, the output will be 0. That all of you know, right? NAND and NOR, these two gates are known as the universal gates, right? Now this is very important. So in this case, you see there are different gates, and all the gates belong to the 4000 series IC, okay? You have the 4000 series IC, okay? Now what are the difference that you obtain? The thing is that in the previous semester you have done the same digital logic, but it was, you have used the 7400, right? 7400 was the series for that, okay? 7400 was the series for that. But in this case, you are using the basic gates or universal gate. All are using the 4000 series. Now you please write it down here, because we will be requiring all the basic gates or the IC number of the basic and the universal gates. You will be requiring the IC numbers of all the basic and universal gates using, we will be using this one in the Proteus. Please note it down. 4071 is used for 2 input OR gate, 4081 is used for 2 input AND gate, 4069 is used for 1 input NOT gate, or it is also known as hex inverter, right? 4069 is also known as hex inverter. It is also known as hex inverter. This is writing here is difficult, still I am trying to write. It is known as hex inverter, okay? This is known as hex inverter, right? Apart from that, you have the other two gates, XOR, and this is also known as, it is also known as XOR. XOR is also known as XOR, right? So this is, I should complete this one. It is, you write it down. It is difficult to write here. You write it down. It is hex inverter. Please note it down, okay? Now I am switching to the next slide. 3 things you need to know. 3 things, please have a note on that. 3 things you need to know. For any kind of digital, 3 things you need to know. Number 1 is the symbol. These are basically the symbol of AND gate. This is a symbol of OR gate, symbol of NOT gate. These 3 are basically the basic gate symbol, okay? This one, and this one. And two gates that are basically known as the universal gate. The symbols are like this. I know you know this one, still I am repeating a bit. And these are the XOR and XNOR. right? Okay. Now if you see this one, I will come to the IC diagram of 74704071. Okay. So in case of 4071, this signifies it OR gate. Okay. And in the basic electronics lab also, if you have used the OR gate, you have seen how will you count the pin numbers. Okay, so if you do not know this is known as notch. Okay, you have to identify where the notch is. Now it is in virtual mode, so there is no requirement to identify the notch, right? But if it is in the real life laboratory mode, every IC when you are putting in the breadboard, you need to understand where the notch is, otherwise the whole thing will be erroneous. How it will be erroneous, I am telling you. Okay, now you can see, can you tell me what are the difference between the 4000 series OR gate and the 74 series OR gate? If you remember the previous semester that you have learned the digital, the 74 series gate that you have used, the 74 series gate that you have used, basically the 74 series gate that you have used, where was the inputs? 1 2 was the input, right? Fine. And 3 was the output. Here also 3 is the output. There is no problem for this gate. Okay, whether it is a 4071 or it is the 74 series OR gate, whatever, 1 2 will be the input and 3 will be the output. There is no problem. But what about this one? In case of 74 series OR gate, you will see the 4 5 used to be the inputs and 6 used to be the output for this second OR gate. Okay, here also that means the two outputs are face to face in case of 4000 series. Okay, the two outputs are face to face in case of 4000 series. Okay, this one and this one. Okay, whereas the two outputs were not face to face. What were the two outputs in case of the 74 series? It was 3 and 6, right? But in this case it will be 3 and it will be 4. It is difficult to write here, still I am telling you. In case of 7400 series, the OR gate or whatever the gates you have used, the outputs were 3 and 6, whereas in case of 4000 series, which you are using or which you will be using throughout the lab, or if lockdown is over, we will be doing the hardware labs, right? So then you need to understand, otherwise the circuit diagram will be wrong, the placement of the IC in the breadboard will be wrong, and the power supply will be, so that definitely the erroneous output will, you will never able to get the same truth table that you have studied theoretically and that you are going to implement. After that you have to get the result, right? So obtained truth table and theoretical truth table you cannot match if you are not understanding the pin diagrams. Okay, now if the question comes in 4071, how many in this is the IC number, right? This is the IC, it is not the gate, it is the IC, and within that IC how many gates are there? Within this IC, this is the IC, within the IC there are 4 gates are there, right? So 4 gates are there. 4 gates are there, right? 4 gates are there. Now within there 4 gates are there. Now what happens in case of the truth table? This one you know, I am not repeating this one. The OR gate I have told you previously. If any of the input is 1, the output will be 1. That is happening here. You can check it. For out of A and B, if any of the input is 1, you are getting the output as 1, 1 and 1. Because here the 1 as the input, here the 1 as the input, and here both 1 and 1. Both are the both the inputs are 1, right? So in case of OR gate, if any of the input is 1, the output will be 1. Okay. Now come to the second gate, that is 4081. 4081 is basically 2 input AND gate. Okay, so in case of 2 input AND gate, same thing we will notice. Okay, one thing I missed out, I should have told this one. The two vital points that I have missed out, what are those points? The power supplies, right? VCC or VDD and ground. Okay, but we are not telling it VCC, we are telling it VDD. Why? Because this is the CMOS based IC. The 4000 series IC is basically, I will ask this in Viva. Okay, the 4000 series ICs are basically CMOS based ICs. Okay, whereas the 7000 series IC is basically TTL based ICs. TTL, transistor logic, and CMOS is the complementary metal oxide semiconductor. Okay, CMOS based logic. So there are two things, two types of technologies rather. Okay, so if it is we know in case of CMOS there is one NMOS, another is PMOS, and if you just combine this two, you will get the complementary CMOS. Okay, and in the CMOS you have the drain, gate and source. That's why due to drain you write VDD, not VCC. In transistor we write VCC, but in that is the CMOS type we write VDD. Okay, so this is the way actually. So this is the very why I have given this one red, because here you have to give this 5 volt and here you have to basically ground it. Okay, you know the symbol of ground, you have to ground this, and 5 volt actually here you have to give. Okay, here you have to give the supply for 5V. So if you do not do it properly, the thing will be reversed and ultimately what will happen? Your IC will be burnt, right? Simulation mode, there is no problem, there is no need of this cutter, wares, how to purchase IC, how to put the IC. You can simply drag and drop and you will simulate it. There is no problem in simulation mode. But in hardware, real hardware laboratory, it will be problematic if you do not know where to give the 5 volt and the ground. This is very, very important. Okay. Now, or I have already told you. So here also in this case same thing will happen. That means there are how many gates are there within this IC? There are 4 gates. This one is one AND gate. This is another AND gate. So there will be 4 gates here also. Okay, similar to the previous, that is 4071. Okay, here also same thing, the ground and VCC you have to give, and this is the notch, right? Now what is the truth table of AND gate? Now in one word what can I say? If any of the input is 0, I am repeating once again, if any of the inputs is 0, so in this case here 0, here 0, and here both are zeros, right? So if any of the inputs become 0, the output will become 0. If both the inputs are 1, the output will become 1, right? This is the way we will understand the thing. Okay, no need to mug up the all this truth table. Understand the thing and do it accordingly. Okay, now question will come. So all the ICs you have seen is 71 or 81, it is having the 4 gates are there within that IC. Now what will happen in case of 4069? That is the NOT gate I told you, and it is the inverter, hex inverter I told you, right? So you see there are how many, this package is a 14 pin IC package. Okay, 14 pin means this one. One thing also I missed you, because it's not a hardware lab, that's why I am missing all these things. When you are putting this one in the breadboard, right? You have used breadboard in the circuit diagram also. So you have used the breadboard, you have circuit diagram also. So for implementation purpose, what can I say? When you are counting the IC numbers, you just find the notch, put the IC in this way, and you just number the, because in the real scenario there no numbers will be given, right? So how will you give the numbering, you should number the pins like that way anti-clockwise. If you put the notch in your left hand side, you place it the notch, then the lower one will be 1, then you just move anti-clockwise, you will get 1 2 3 4 up to 7, then 8 9 10 11 12 13 14. There may be some ICs that will be having 16 pins. Okay, so in this side 8 pins will be there, in this side another 8 pins will be there. Okay, now in this 4069 IC, how many gates are there? There will be basically 6 gates. Okay, the question will come, in case of 4071 or 81, how many gates? There will be 4 gates. In case of 4069, how many gates will be there? There will be 6 gates. Okay, now I will come to the next slide. I am not talking about the VDD and ground, you know that one, right? Now the inverter truth table is very simple. You have the 2 inputs, right? And if you give 0, the output will be just opposite 1. If you give 1, the output will be just opposite 0. So very simple, whatever you give, that's why it is known as inverter. Okay, now come to the special 2 ICs or the universal gate ICs. Please note the numbers. Okay, this is very important, number and the name of the IC. Okay, pin diagram also is important. Here also the same thing, I am not repeating it because 1 2 will be the input, 3 will be the output. So 3 and 4 is the same output, 11 and 10 will be the same outputs, right? So 4 ICs will be there also, right? So we will be using mostly 4011 and the next is 4001. Anyways, so this is the gate of the NAND gate. Okay, so NAND means not of. This is not of. This is very fundamental. I think most of you know this one. Still I am just telling you, not of AND. Okay, whatever is the truth table of AND gate, if you just put or if you pass it through a NOT gate, you will get the NAND gate. Okay, whatever is the truth table. So if you what is the product of AB? 0 0 will give you 0, and if you pass it the 0 with the NOT gate, you will get 1, right? So in case, if I am just going to the previous slide just for sake of example, the first, in case of AND gate, first 3 were zeros and the last one was 1, right? So definitely in case of NAND gate, what will happen? The reverse thing will happen, right? That means the first 3 things will become, not of 0 will become 1 and the next will become 0. Okay, so this is the way we actually form the truth table of NAND. Now come to the NOR gate. Only the symbols are changing. As of nothing is changing except the symbol. Same 4 gates are there. You have the notch, you have the power supplies, you have the 3 4 as the output in this side. Here you have 11 and 10 outputs in this side. Okay, now quickly come to the NOR gate. This is not of OR, right? So what in case of OR gate, if one of the input is 1, then the output will be 1. Here if the reverse thing will happen, so the first case will become 0 and the next thing will become, the first thing will become 1 and the next thing will become 0 in case of NOR gate. Okay, so these are the 2 ICs and you can check it. These are the same thing. I will not take too much of time. I will just go to the Proteus part. Okay, so this is the 4070 XOR IC and the same power supply, output, notch and all these things. Nothing new in it. Okay, now can anybody please tell? You okay, you can't tell. Now so what is Y? Can you implement this Y? So Y is basically the XOR gate. What I told, this is also known as simply XOR. Okay, I think whiteboard will be better. So anyways, so what is the, it is a symbol, right? Plus encircled is basically a symbol. How will you just increase this one, or how will you just expand this one? Basically it means that it is a bar b and plus ab bar, right? It is a bar b plus ab bar. As simple as that, is ab bar. Okay. Now the thing is that 2-3 things that I will tell you regarding the Proteus. It is a EDA tool. Okay, electronic design, that means you can design the electronic circuits here, EDA tool, and you can design different types of embedded system design also you can design here in this platform. Okay, you can create different PCB layouts here. Okay, next microcontroller based projects you can do here. Okay, or IoT related projects are there. Okay, now you can see that, that there is one I think lab center is the lab center. You can see from where it has been created, lab center I think. So you can check the website, there it is written what are the application of this, means they have the IoT builder module, they have the embedded peripherals module, and different PCB design layout modules also they are having. So they have a strong background, that's why we have selected this software to do this. Okay, now let's come, those who have already installed it, please have a look on this, whether you are getting. You go to the search button here, you can go and you can type this one Proteus. It will come like this. It will take 1 minute of time and it will come like this. Okay, in the search button of your PC you type Proteus. Take your time. I will be, because I am not doing this one, I will be doing it later for your, or you can take the snapshot by your phone also for sake of your the steps you need to know. Okay, so if you write here in the search Proteus, you will see the Proteus icon. If you click there, you will get this suite here, right? Now if you click the new project, you will just launch a new project. The window will come like this, and in this case you can see they are asking for the project name. So the problem most of us used to do, we just whatever name it is having, we just give next. Please do not do that. You just select a name, like you are doing experiment 1, right? So in this case I have written experiment 1, right? exp1. exp1 means, you see I have given, I think it is visible to you, right? Instead in the previous slide it was the by default name, and this slide I have changed this one to exp1. Whatever the extension it is having, it is kept unchanged. Okay, now if you go to the next slide, there is the option, please do not select anything for this moment, you just select next. Okay, because we do not actually, we are making a schematic of this, so we are not putting the first option. By default it will come, and you just select this one and you just click next. You will get there, right? And after that, if you select this one, you are not creating any PCB layout, right? You are just putting the components in the panel and you are just making the small circuits. Okay, so you will get it right here. Okay, and if you click here next, no need to select anything, just click next. Okay, and after that you click the finish button. Okay, simple finish. So I think you are getting this type of layout. I think many of you have texted me with that after properly installation you will get this type of panel here. Okay, so take your time, do it slowly. Maybe I am a little bit fast in this portion, so you take some time and do it. Okay, now actually what I am doing this one, I will share this slide to you so that you can have the reference and you can do it by yourself. Okay, I will share all the PPT, whatever we will be doing, we will be sharing all these things in your official group. Okay, Now the slide is the next. This P, what is this P? This P is basically the peak device panel. Okay, so what you have to do, you just click the P, the peak device panel, and after clicking P, what you will get the, you see here it is a peak device, right? So it's under the keyword, it will be a blank, right? So here you have to write the IC number. Okay, here you have to type the IC number. Maybe you are typing this 4071. So 4071 you can type it here. After that you will get this one, a panel of ICs you will get. Okay, if you get a panel of ICs, what you have to do, you select the first one, not everyone, you select the first one, not the others, right? There are other ICs also, DM, LC and all these things. You just select the first one and you click OK. This is the OK symbol here, you click OK here. Okay, after clicking OK, what you will get, after clicking OK, you can see under this device you will have this 4071. Okay, you have this 4071. What you have to do, I will just literally do, I will do by this time, just after showing the PPT only I will do the hands-on. Okay, so after this what we will do, we will just click here. I'm just going to the previous slide. If you just click here and then you click here, one pink icon will come first, and then again you click here, then the IC or the gate will be situated in the panel. Okay, I will be doing, you just click here, you will see this one. Okay, now how to magnify, because this is very small. Okay, so this button is there, the magnify button is there. If you magnify this one, it will become in a larger, you zoomed out format. Okay, so you can see another thing, the green border line is here. This is a panel you want to select. Maybe in many of the cases what happens, if you zoom too much, you cannot see where you have placed the gate, right? So you have to just change the greens, or you can scroll this green line in such a way that you can see the IC in the proper position. When I will be doing, you can see what are the real-time problem that happens. Anyway, so placing of the IC is done. I think up to this it is clear. So what we have done, initially we have clicked the panel P, then the panel came where we have tied the 4071, then we have selected the first one, then we have used OK. After that 4071 came here, then I have clicked once in this 4071 and double clicked in this panel. You have placed the first gate. Why it is known as U1A? Can anyone tell me why it is known as U1A? In one IC, how many gates are there? 4 gates are there, right? So out of 4 gate A, B, C, D, they are internally giving the names. Okay, so out of 4 gates they are using the first gate. That's why the name is U1A. If we are using the second OR gate of the same IC, you can see that while we will be doing the experiment, it will be U1B, then U1C, then U1D. Like that it will happen, right? So in one IC 4 gates are all used. So U1 is over, right? What is the next thing? Next you have to do something. How will you give power to this and how will you get the output? That is the normal question. You have placed the IC, but how will you give input and output? That you have to decide, right? So you see, for input, this is the thing I am doing it. This logic state is used for the input, right? This will be using for input. This logic, write the logic state in the same place, right? Logic state. So if you write logic state here, definitely you will get the same type of panel here, device, library, description here. Okay, now if you click it, if you just click it and click OK, the OK part has been cropped out anyways. If you click this one and use the OK, what you will get, similarly like the 4071, after OK it came here, right? Similarly the logic state, you will search it, you will select it, you will create, or you will just click OK, it will again come here. Okay, so whatever the ICs you are planning to use, one by one actually we will be clicking in the pick device. The pick device panel will open, then we will write the IC name or the input or output name, then we will select that one, we will click OK. After that will come to device category, right? After device category, what we will do, we will just select this one and we will double click here. Definitely the logic state definitely come here. Now see in the next slide what happens. You see, it's not two things did not came. Initially I have skipped one, print screen actually. You have to just select this one and you click it here, it will come first, then you select it here, then double click here, then it will come. So 2 times I had to do, that why 2 inputs came, right? And initially it is showing 0 0, right? So it is 0 0. Now the next thing is what? Input is done. So what about the output? So output you have to again go for which area? Again you have to go for pick device. Okay. Okay, one thing I missed out. After this actually you need to connect the input and the inputs of the pin IC, that's a pin, right? So what I have to do, after I have done the connections, then I have again created shortcut. You just click it here and you can see automatically a wire will be dragged. You see what is the advantage of doing this type of simulation? You need not to go to lab, you need not to cut the wires, you need not to find whether the ICs are working properly or not, because in hardware lab if you go, you will feel the lots of problems are there. Maybe some breadboards are not working, you do not know, you have to check the breadboard connection also, the power supply connection also. So lots of hazards are there while you are using the real-time hardware. But software it is very difficult. You are just searching for the icons, that is the IC or the logic state or the logic probe, you are selecting that one, putting OK, it will come under the device category, then one by one you are putting in the panel. Okay, now what will happen here, I have searched with the logic probe similarly and it came here. Okay, then what if I click it here and click here, you see this type of question mark box type, this will come here. Okay, now if you place it here, what will happen? After that I have used the wire connection. So wire connection you have to do it separately. Okay, don't rush, please take your time, do it slowly. I am just making it faster because I at least have to show 1 or 2 simulation. Please do it slowly. Okay, no need to rush, and because the fundamental needs to be very clear. Okay, so this is the way you can create the circuit. Okay, so it's a very simple one. Now the circuit creation is done, the connection is done between the external wire between these two and the output pin. You see, you can say greenish type of wire is there. This is a brown type, and this is the wire is a green type, right? Now what is happening, how you need to debug and simulate it, right? Otherwise it will not work, right? How to debug and simulate it? You need not to use some external thing, whatever is there within the software itself. Okay, so I will show you in the next slide. You see in the debug panel here, in the debug panel, you can, all of you can see this one, you have the debug, right? So in the debug, if you click it here, you start SVM debugging. Okay, so actually if you click this one, it will automatically start debugging. If it is started debugging, then what will happen? What will happen then? You can then run the simulation. After it stops debugging. Okay, so it stopped, right? So then you click the run simulation. Okay, so if you click the run simulation here, you will get what? you will get see, if the run simulation you are giving, actually after this I have put this one, okay, this is the separate, this you will get, okay. This is the another Word file that I have given in your official group, right? Some document you have to make. I will show you how to make it. It's simple. You write down the title. That's why initially I told you please write down the title. Okay, what is the aim? You are not just verifying this one. Now what do you mean by verification? Theoretically you know what is the output of OR gate, okay. So what is the output of OR gate? Theoretically, if any of the input is 1, the output should be 1. This one should be 1, this one should be 1, as well as this one should be 1. So I am writing this one 1, and this is also 1, and this is also 1. Okay. Now you have to check every time whether it is coming or not by giving the inputs. If you click here, I am not clicking here because it is a static picture. If you click here, the input will be changed to, see, if you are clicking, I have clicked the second part, that's why it has been changed to 1. Okay, so you see, so you have given 0 input and then 1. What is the output you obtained? 1. So your validation is correct. Whatever is the theoretical value and whatever is the output practical value, both are matching, right? So you have validated this input pattern of this out of the 4 patterns that I can see. I am coming to the next slide. I am changing the pattern. I am changing it to 1 and 0. If I change it to 1 and 0, definitely what is the output that will come? This one, 1. So I have again 1 because the previous slide you see, it should be 1, it should be 1, and it should be 1. That is a theoretical aspect. And you got it 1 here, you got it 1 here, and for the last case, if both the inputs are 1 1, then what will happen? If the inputs are 1 1, in case of OR gate also, the output will become 1. Okay. Now the thing is that this is all about the thing. So our validation is done. So whatever is the theoretical output, that will happen, and what we are getting are perfectly matching. Okay. So this is the end of this session. Now I will come to the Proteus software. Okay. So just wait for 2 minutes. Okay. Now in my desktop, Proteus is already opened. Okay. So, and even you see, after making the files, you can see that the files will be stored in the recent projects. You can check it here. The recent projects, the files are stored. Okay. Now if I want to create a new project, and more of the thing is that suppose I have created a project. Okay, so let's try with a new one. I have clicked the new project. That is the first step. You can write it down. If you have just forgot, then please write it down. First you will click new project. Okay, it will take a bit of time. You see, again this same thing is coming for me also. Okay, same thing is coming for me. Now already exp1 I have already stored, right? I cannot make it again exp1 because I have already saved the file. Okay, let's take it test11. Okay, please do not give any space. Do not give any space here in the project name. Okay, so if it is like this, you just click next. I am not changing anything, not clicking anywhere, just click next. Here also you will click next. Okay, again do not create, we are not and again you create next. Lastly you create finish. Okay, after finishing this one, what I told in the slide, this type of panel will come up. It will take a bit of time, please bear with that. And you can see here the test11, whatever the project name you have given, that is coming here as test11. Okay, it is coming as test11. Now, what are the steps I told you how to do a simple expression or how to implement a simple thing? I have shown you how to do with OR gate, right? Let's start with AND gate. Okay, so what is the IC number of AND gate? 4081. Okay, so I will search the panel P. I am doing it slowly, searching the panel P. Okay, so many of you asking many things in my WhatsApp actually. Okay, you can okay, I'm telling you, you can just undo the thing so that whatever you have placed, that will be removed. I think this is Shubhecha, right, from 2G. You can undo the things, so everything will be altered, like the word in Word or whatever the way you have used to do the things, that you need not to delete everything or you need not to start it from first. Okay, so the thing is that I will send all the documents, no need to worry about that. I will send all the documents. Now 4081 is the IC number. I am just clicking this one. I think it is visible to you, and if you click this one, you see lots of things are coming under the device category. Okay, so which one you are going to select? Which one you are going to select? I select the first one. Okay, quad 2 input AND gate, and you please click OK. Okay, now after this clicking OK, you see under the device category 4081 is placed here. Okay, 4081 is placed under the device category. Now the thing is that, what is the next step I told you? The next step is you have to click once. I have clicked just once, and again I am click it one. You see a pink color box is coming, right? It's not the original, it's not placed at all. Okay, again you click it now. So you need to double click it in the panel, so to place the IC from this panel to here. Okay, now it is very small, right? It is very small. You need to check this one. How will you need to check this one? You need to magnify this one. The way I have told you, you need to magnify this one using this zoom in option. You can see in the upper panel there is a plus and minus sign. Zoom in, if you click zoom in, it is just it's getting enlarged. And again, what I was telling, that if you zoom more, you will not able to find the IC, right? So what you have to do, if you zoom too much, it is getting dragged in this side or in that side. So what you have to do, rather you see a green color border line is there, right? You just drag that one here. Okay, you drag the green color border line here. Okay, and you see it is placed. Done. Now IC is placed. What is the next thing what you have to do? That is the input output. What is the thing? I am just typing it here. Just first you place the IC. Second, what you have to do, the logic state, and third you have to is the logic probe, right? PROBE. Three things. Now the first part is over. Now I will go for the, then I will go again. This is for your reference. Okay, I'm just minimizing this. So you go to the big panel. I write the logic logic state here. It will come like this, right? Under the device category you click it and then click OK. Okay, after clicking OK, you see the logic state is here. You can check it, the logic state will be here. Okay, done. The input is there. You need to just drag and place it. Now you must go for the output. For output you just go for logic probe. The logic probe, PROBE, LOGIC PROBE. If it is there, then you click the first one, the simple logic indicator. Okay, and if you click OK, the logic probe also will come here, right? So what I am doing here, logic state the input, I am just clicking single click and you click, the pen will come, single click, pink notation will come, again you click, it will be placed, right? Again you go to the logic state, single click, again click it here, it will come. Done. The inputs are done. Now go to the logic probe. Again, okay, so after doing that you go to the logic probe. I am placing the input output, then I will connect it. Okay. Okay, if I am going too fast, please you can send me WhatsApp that it's not the fast or any modification that you require, please send me, because I will tell it later, because if I see WhatsApp then it will be difficult to tell you all these things. Okay, so anyways, so so logic probe, I am clicking it here and I am placing it here once. Done. You just double click here and it will be placed. Now the thing is that you have to connect this one with the input, right? You have to connect this one with the input. So simply you will just, red box will come, you just drag it and here the red box, it will just drop it, it will be connected. Okay, very simple. So that's why there are few points that are used for this they are used for this type of method, that see very easily debugged, right? Whenever you are making the circuit flexibility is very easy. You can easily implement this one. You can fix the bugs also as fast, because if you have really some hardware circuits and where you have done all these things in the basic electronics lab, I think you know the problems, because if you are connecting also still the outputs are not coming and all these things stuff you have faced. So just bug checking is a huge time consuming task for you as well as for teachers also, but here it is very easy. You can also debug it and just simply run, and you can also check whether it is running properly or not. Okay, okay, now the second thing, I am just the second where, okay, so Shucheta, I was telling you, just I have done this one mistakenly. So what I am doing, I am doing the Control Z. Control Z, if I do, what will happen? You see the where has been erased. So what I have done, simply use Control Z if you have done something wrong in the previous step. Okay, now the where connection is fine, right? So if the where connection is fine, what we can do, we can do the where connection for the output pin number 3 and output this one, output probe, right? So this is done or not, who is going to tell us? I have to do what? I have to go to the debug section. If I go to the those who have not installed till now, for them I will again give some doubt clearing sessions. Please maybe in the weekend or something like that, you can talk to me, we can create a Zoom meeting and we can also sit for the doubt clearing. Okay, no need to worry at all. Okay, so don't get tense, you are not understanding, you are not capable to install it. For this week we will be doing this one, and if any kind of help, we will be telling all these things in Google Meet also. Okay, so no need to worry. Okay, you just send me a text that you are not done, then we can create some extra doubt clearing sessions. Okay, now the thing is that it's not yet done. you have to go to the debug. Please understand the thing, and you can take the snapshots also, or I will give the PPT to you also. You go to the debug, that steps I told you. Go to start SVM, and if you go to start SVM, what you can check that you can see 2 messages already debugged, right? So if it is done, what you have to do, you please go to this again debug section. Again I am going for the debug section, and what I have to go for, I have to click the run simulation. In the PPT I have already told you, after starting or ending the debugging, then you have to click the run simulation. Okay, and if you do the run simulation 1, if you click the run simulation, you can see whether it is changing or not. Hello? Okay, so it is changing or not, that we can check. Okay, now how will you create the Word document the way I have done? I think I have forgot to put it here. I have to go to my desktop and I have to just wait 2 minutes. And so then it is the digital logic, the lab session, DLD week 1. Okay, so this is the every page header content the way I have. I am closing this one actually, because I hope it is opening. My system is a little bit slower, so anyways it will take time to open. Meanwhile we will go for this. Okay, we will check this one, meanwhile the Word will open. Now see, for the AND gate, now it is opening. Just wait for 2 minutes. Okay, so what I told you, that in the you have every page must have some header, right? So if this is not visible, those who are not having the Proteus also, they can also write a simple Word format. You write your name, section, roll number, and maybe the document, the questions that I have given, you can also do with that. Okay, no need to be get tensed or panicked. Eta hocche na ota hocche na sob hobe. Okay, so the first OR gate I have done, and I have created the video. Okay, so the next is the AND gate. So what can I do? I can minimize this one and check whether what is the output and what we are getting. Okay, now I think you can zoom minus. Okay, and you can just tilt this in this way in one side, so that in other side I can keep the Word open. Okay, now so what is the gate number? 4081, right? Or here, instead of this, what can I write? Here in the IC number is 4081. Okay, so what are the truth table? It is 0 0 0 0 is the binary of 0, 0 1 is the binary of 1, then 1 0 1 0 is the binary of 2, and then you have 1 1. Okay, now can you tell me, if you have too many things, okay, definitely, thank you. I do not know your name. Very good. Shoham from CS2A. Very good. Definitely it will be product. Very good. I think you people are noticing. I am just privileged that at least some of you are viewing these things. I hope it will create some enhancement in your knowledge. I am not a very good teacher at all, but still I will try to make things easier for you, right? So if from my side, if you feel any problem, you can definitely communicate with me, because we are doing it all live, right? So teachers might have some mistakes, and thank you, Shoham. Okay, so what we can do that, this is 0 0, right? So 0 you can check. So 0 0, if you say 0 0 is giving 0, so here also I can write 0 0 is giving 0. Now it is 0 1, but the output will give you again 0, 1 0 will give again 0, and 1 1 only give 1. So that I have to check. Okay, so please check whether it is 0 1 is again giving 0. So your simulation for the second is correct. So is second one is again giving 0. Then if you go for third one, that is 1 0, then it is also giving 0. That we can write it here. And the fourth one is, if you put both the things 1, then what will happen? It is giving 1, right? It is giving 1. So I can write it here. So I think 5%, 5 to 10% doubt is clear. Those who have installed and those who have tried a little bit out of this. Okay, so you just save the file, save the document file. Okay, and you just change the file name in the way instruction is given. The way instruction is given, you please change the file name. Okay. Now see, one thing is coming, real time simulation in progress. So what I have to do, actually I have to stop the SVM debugging, otherwise you cannot do anything extra, right? So this is the way actually you can simply implement the basic gates. Okay, now what are the other gates available here? You can use, I'm just putting it here, the gates like 4071. Okay, I'm just making the thing habituated to you. I'm clicking OK, that is 4071. You can place it here, double click, and you can click it and you can place it here, right? So for your, or if you do not right, so this is the thing. Extra, what are the thing we can do? 4069. See, those who are not having the laptop, I think you can share with your friends. You have some close friends, at least you can create some close meetings and you can create. And meanwhile I will be searching for any alternative. Those who are not having, they might use the online Tinkercad, because those who whatever it is, it model sim or is it Proteus, you require some software, right? Otherwise online simulated only that can be happen using the Tinkercad. But the Tinkercad problem, I am telling you, for Tinkercad the problem is that all the ICs, 4000 series ICs are not available. That is the problem. Otherwise we should have used the Tinkercad, but 4000 series IC, which if lockdown opens, you have to do it, the 4000 series ICs in the lab. In lab the 4000 series ICs are there. Okay, so if you are doing here in 7400 series and you are doing in the digital lab 4000 series, so there will be a phase change, right? So I do not want that, that's why. And secondly, you can create you learn the software a bit, so that you can use the software in the coming days for your future project work, maybe final year or in between any project work. Because you can, if you do a good project, if some novelty of work lies in your project, it can be published in a good journals or good papers. And in IEM, UEM, lots of people are creating different conferences out there, and you people are welcome to have your innovative, to put your innovative ideas. You just stay together, you create a group, and we are just telling you the pathway, and ultimately you need to dig the path, right? Otherwise everything teacher cannot, even our teachers have not able to show us all these things. Okay, I congratulate Shayon. I think Shayon is there or not, I do not know. Some of your friends told me that macOS was not working, but Shayon today morning told me in the WhatsApp that ma'am, because it was really pathetic if some of the people are working and other people are not working. I will think over that. What are the alternation for the people who are not having the PC and all these things? Definitely I will tell. And meanwhile, those who are having, please bear with that. Okay, and the size is also big, that also I know, but anyways, those who are having problem, Tinkercad also I will tell you in another meeting if time permits. Anyways, so this is 4069 also. I am clicking and I am putting it here. You can see 4069 is here, and you double click it and this one. So some of your friends are telling about the NAND and NOR one. I think Aryan Gupta, I do not know your section, but you are telling that NAND NOR. Definitely we can use NAND NOR if you just click, and 4011 if you put it here and you just click here, and you can see 4011 is here. Okay, you just click it and it will be there. So I am placing ICs and the connection will be same. How will you check that one? You see, I am just putting the input here. Sorry. Okay, and the output actually, that input is you can take from common for different gates, right? But the output you have to put separately. Like probe part you have to put separately. Okay, like for this I am creating the probe, I am connecting it. Okay, and for maybe I have actually placed it in a different positions, so that's why it's not aligned. I will show you the demo what I have created. So can I run this one? So you can see that, you see I have not connected, only the AND gate and NOT gate I have connected. Okay, so if I just again start SVM, it will simulate. Okay, and again if you run this one, you see, you check it once, you see this 1 and 1 are going to this section. Okay, so it is giving 1, that's fine, but this one is again coming to the input of this NOT gate. So what is the output? 0. So it is giving the accurate output, right? I think it is giving the accurate output. So if you create a circuit, I will show you. I think I have okay, so I think more or less it is clear, right? So I need your response, right? I cannot take it now, but I definitely WhatsApp, I am getting responses, lot of responses I am getting you. I hope few things, I think 50% doubt is clear. While you will be doing hands on, you will see lots of things will happen. Okay, now where the files are getting stored, that I want to show you. Suppose you have created the test1. I do not know where it is stored, but I will just check it. Generally in my case, in the documents the file is stored. I will just go to the document. Okay, if you are having the net problem today, actually I do not have any this just I have to check whether the file is stored. The name is I think test11, right? Okay, so see, I am done all these things. It's not done, I am just saving this one and I am closing this one. Okay. Now you can ask me, ma'am, from where I will get the saved file? If in my case it is getting stored in documents, you can see the document is there, the files are getting stored, and this file will, if you click this one, you see it is opening in Proteus. It will take 2 minutes of time. See, all the things that we have done has been stored, and if you just maximize the thing and you just change the screen, the green border line in such a way, in such a position, then it is showing the previous circuit that you have made. So whatever you are saving, please understand where you are saving. So everything will be saved. After that also you can create your other types of simulation on the same file. Okay, so try to solve all these things. I hope you have liked a bit. It's not a full like, but still a bit you have liked maybe. So I try to improve the teaching methods because we are also new in this online platform, especially in YouTube Live. So if you are having some problem, I have seen lots of problems are there, so I will sort it out one by one. Please give me some time so that I can sort it out, right? So if you are facing any license error, it happened to Priyanka Chatterjee. I do not know from which section she belonged to. So Priyanka faced the same problem in the morning. So what she had done, she actually downloaded the same thing and again installed. I think there is some problem in the installation. Okay, so that will create the license error. Okay, please no need to download it again. So you please try to install it, uninstall it and install it once. It will create the proper Proteus version. Okay, I hope this is fine. So what we are going to tell you today, that I will share a Google form by this time, and you please fill up the form. I have not given too much of questions today. So if you are having the software, please update it with snapshot. If you are don't having the software, please listen carefully. Please try to write it in the white page and you just scan and upload for this week only. Okay, because we are considering your case. Many of you are telling this one, so I will not take too much of your time. I will just close this session quickly. Okay, before ending the session, I am just telling you experiment 1. Okay, I have created yesterday, so from where I have okay, I will keep the video, so please try to go through it and learn slowly. Okay, so you are requesting me, I will try to keep the video. While you are texting, please mention your name and section. Okay, I will send the Word file. You can there is no format of the Word file. First page, like Vipasha madam told you, the first page, complete your details, the name, section, enrollment number. You see the okay, for each page actually you have to please don't copy. Okay, because you people are enough capable of doing that also. I have faith on you that you people not do that. So anyways, because if you are doing so, you are cheating yourself. Okay, so please do not do that. Be truthful to yourself, be truthful to your profession. Whatever you do, you please give time and you please do it dedicatedly. Okay, take your time. I will keep the response up to 4:30. Okay, so take your time because questions are not too small, so it will take time. So I will come to the solution one by one. Please give me some time. So now I am just closing the session. Okay, so thank you bearing me. So I am not a good orator, you can say. I am not. Okay, so thank you all. I will just solve the problems. I will see the chat box, solve the problem one by another. Okay, I will just, please give me some time. Okay, I am just ending the session, ending the stream now.